Okay, this is going to be a series of videos, so the one you're watching is only one of a series, and I do encourage you to watch the rest of them. Also, I encourage you to watch the full-length webumentary titled Global Warming, Myth or Reality, A Skeptic's View. It goes through the entire science behind global warming, but with this series, we're going to pick and choose some interesting pieces, and we're going to ask the viewer, does global warming pass the stink test? We're going to take a look at the science, and I want you to ask yourself, does that even make sense? Most importantly, ask yourself, if a big oil company produced a report like that, wouldn't the environmentalists be going ape nuts? Because what we're going to do is we're going to take a hard look at the science. And then once again, just ask yourself, does this pass the stink test? Okay, another principle with science is that you want to hold as many variables as constant when you're doing these experiments. That's why you have what are called controlled environments, where everything is held equal, and then they try to vary one variable or another and measure the impact it has on the dependent variable. For instance, if you're doing something on weight gain, you would want to make sure that you maintain caloric intake, but vary your exercise to see how you would lose weight. The one thing you would never want to do is have something where you have totally dissimilar variables. Let's say you're doing a study on weight gain, and for the first half of it, you're measuring the impact upon sumo wrestlers. And then you're measuring the impact it has on them. And then the second half of the study, you do your study on supermodels. Okay? Now, if you're trying to show weight loss due to one factor, you clearly see that a sumo wrestler, if you do something, is going to lose a lot more weight than a supermodel, simply because the supermodel doesn't have that much weight to lose. So you would never want to use population sources like that for different halves of your experiment, because it just simply wouldn't make any sense. There's too many variables are different in the two studies. Now let's take a look at what they've done with global warming in the CO2 chart. Now try to think about the most dissimilar places in the world. Well, you'd probably think the equator and the poles. That would be a good guess. Now, why would you ever, if you're going to do a study, use two data sources from two totally different parts of the world if you're trying to show a consistent increase in one variable, naming CO2? Well, that's exactly what they do. If you take a real close look at this chart, you'll see that the left half, the part that's the white line, comes from ice core data. It comes from the Arctic. It comes from an area where there's no biomass. The second half of the data, the yellow line, comes from Mauna Loa. Okay? And so what you can see is they have violated the principle of ceteris paribus, or all else held equal, about as bad as you can get in order to make their case. Now, the only reason I know of why a scientist would do this is because the data that they have that is consistent isn't supporting their argument. And so basically, this is a way that you lie with numbers. You don't expect people to take a hard look at what's going on, and they don't expect you to understand the principle of ceteris paribus. However, scientists do, and this is a big, big, big violation.